Welcome G. Let's start a Java tutorial. Today, uh, I'm going to discuss about the Java stream. So here we are discussing what are the streams and how we are going to use streams. Okay. So this streams concept was introduced in Java from JDK 8 onward. Okay. If they need a prerequisite. Okay, so please JDK 8, 9, 10 and latest 15 you can use this Java stream. And before Java 8 if you are working on a Java 7, then it's not work for you. So please use Java 8 or latest version. The example which I am going to show you. So let's discuss first key what are the stream, what are the stream, and then we discuss where we are going to the use stream, and then we're talking about the pipeline as well as. And if you're talking about the pipeline, pipeline is a sequence of aggregated function operation. So what is the aggregated operations? We'll look and discuss what is the aggregated operation as well as we are going to look aggregated operation like a filter, like a for each. These are kind of operations. Okay, so first let's discuss about how you define a stream. Till now we have a study the collections. Collections is the list of your object, your list of item that we have discussed last collection like array list, hash set, hash map. These are the stores your similar kind of your object. So similarly, what the sequence? Sequence is a stream is a sequence of elements. Unlike a collection, but it is not a stream is not a data structure that store elements. Okay, so all the collections what we discuss about like array list is a collections is data structure that stores your elements. But streams are not a data structure. A stream is a sequence of element that come from your maybe your data source, maybe data structure, file system, any other sources. And one by one sequence of elements are going to the process in stream. Okay, so stream uh, carries value from source through pipeline. Okay, so here we pipeline is we have discussed pipeline is a sequence of aggregated operations like a filter for each map we discussed now. Okay, and what are the stream? Stream is a sequence of element that can, this is not a data structure, it is carry or process one by one element. Okay, that process inside your stream. Okay, so pipeline is a sequence of aggregated operations. Okay, aggregated operation like we'll discuss for each your filter, your map. These are the your aggregated function. So this aggregated function, let's see, we have a aggregated operation or function. We can say aggregated function 1, aggregated functions 2. So these if you are a aggregated function 0, if this is the one kind of a sequence of your functions, function 1, function 2, maybe this is your function like your filter, like your map, your for each. These are the, if we are performing sequence, known as a pipeline. But this function need a data element on which the particular function of perform, that is come from your sequence of your element. The sequence of element is your stream. The stream can provide data to your sequence of functions, and stream is not a data structure. So stream is need some source of data from data storage, data structure, maybe your file system, maybe your collections like array list. So one array list of data you are retrieving from your data source, and that is passed to your function, and sequence of function perform on that data, that sequence of operation known as your pipeline. So it's clear. Stream is a sequence of your element, pipeline is a sequence of aggregated operations or a function. Clear? So these terminology are sequentially we are going to use like pipelines and stream. Okay, and the collection we know. So first we need a data source, like maybe any collections, or maybe any file system, or maybe any data source. Okay, from this data source we are build we are build some uh, set of your operations, set of operations. So my relative operation on a function 1, function 2, and function 3. Stream is just a sequence of your element. Let's keep sequence 1 here, come, and that pass to your function 1, then function 2, then function 3, then your output. Next element pass. So this sequence of element is a stream. Okay, and set of functions which are going to perform on this stream, it's a pipeline. So these are the we have discussed. Pipeline is a sequence of your aggregated operations. Okay, and your stream is a sequence of your elements. So please note, a stream is not a data structure. They are not store any element. So this is the very key element. Stream is not a data structure. Just stream just carries your element from source through pipeline. This is the major. Only the taking input, taking carry data from your source through the pipeline. So let's examine when we are talking about the pipeline. So what kind of functions, yeah, operation can contain? So generally, pipelines have a following component or a sequence. You can say pipeline have a like three major component. You can say one is the source from where the data come, maybe array list. After that, 0 or 1 or 2 intermediate operations, like we'll going to discuss what are the intermediate operations. Intermediate operations will look like your filter and a map. Okay, and last often is terminal operation. So here it look like this is the pipeline. Okay, pipeline your in pipeline your first operation your source of data, then next set of let's key function 1, function 2, this is the function 3, this is your intermediate operations. A third your operation maybe function your terminal operation. So this function 1 is the take one element and process and return another stream to function 2. Function 2 needs some input stream, then pass to function 3 on the stream, and then this again function 3 return another stream to the final terminal. Final your terminal operations return the actual value, what your value needed. So these are the your source, maybe they take data from your array list, your file system, anything. After that, we have set of operation 1, operation 2, operation 3. You can say function 1, function 2, function 3. These function take input as a stream of element, pass to the next function as a stream element, stream of element, next as a stream of element, next to stream of element till your terminal function, and terminal function return an actual value. They are not returning again a stream of element. Okay, so this is the pipe. Now, why this is complete known as a pipeline. The pipeline needs kind of a stream of element, then a stream of function, and then finally return the value. So these middle operations known as your intermediate operations, and this is your terminal operations. So let's discuss same I have discussed about the source. Source, this could be a collections, an array, or any generator function that generate your stream, or any IO input output channel. This can be source. So the source is an collect maybe collection. Second, we have discussed zero or more intermediate operations. Intermediate operations such as we have discussed filter, map, that produce a new stream always. Okay, uh, these all the intermediate operation returns always on a new stream. Okay, so that next function can take this stream and perform our business logic and again return a new stream. So this is the behavior of your intermediate operations. Intermediate operations after doing the processing of the business, they produce one new stream. And third, your final operations. Final operations such as we discussed for each that produce non-stream result. So all the terminal operation are going to actually return the value. They are not going to return kind of a stream again. Value, any primitive value you can return like your double or any collections, your list or anything. Or might be you have just this output. So these are a very key component of your stream work on the pipeline. Pipeline is a set of functions. Each intermediate functions produce a new stream of data. So let us one example, then we'll discuss how this look like. If look, this is the your list of roster, and then this is the first how to start your stream. You getting the stream method, then you have the filter, and then we have the forEach. So this is your stream start stream from your source, and these are your intermediate operation. This is finally you are just printing your value, and this is the forEach. So this for each functions are filter function known as your aggregate operations. Okay, let us write how same example works. Here in this example we have a one. Let's we have created one person class, and they have a like a name and date of birth and maybe gender, maybe email address. These are the things. So how will do? Okay, so let's write one class person let's key they have a some kind of a string, private string name. Let's key they have a int, private int, let's key age. Okay, let's key we have a kind of a private uh, one, what what is this? 6. Okay, 6. First we have to define maybe male or female kind of enum. So we have to define your enum. This a possible value maybe male or female. Okay, so these are the attributes. Just let's create a kind of a constructor. Okay, and then let's create your some getter setter for this, and we are create. That's done. Let's create a toString. Okay, this is the way we have created your Pojo object, and now we are going to uh, uh, create a function static that return the list of your person. Get persons, get persons, and that just in case return list of, we have a list of person we have to return. Let's here we are returning the new person, and let's key we have to create your one. This is the name, maybe same age, maybe 45, maybe male. Okay, and this way this is the let's keep person 1. Let's we create person 2. Okay, similarly let's create some list up. Okay, so let's Sam, Sarah, let's keep female, and then we can say 40, then that Tim, that 55, that's Emily, that let's your 34, and female, and let's Jara, and they have a female. Let's see is about 20, 40, 24. Let's have a cook. Cook is like let's 35. Let's another Spark. The Spark is 50. Uh, Peter. Peter is again 45. And let's Jack. Okay. Jackie. Jack. Jack. Let's 60, say 60, and I guess epa, epa, right? With with is 28. So let's this list up your collections. Now here let's key I want to uh, check a function like now we have a function like get person that return your list of persons, and now I want to just uh, the stream have a function like your stream. So list is a stream function. Now is the stream just I want to print all for each. So for each is a take a consumer interface, and you have to consumer interface and define the implementation. So you can directly write if you for each function take consumer interface, and consumer interface have only one uh, abstract method, except you can give this as a functional interface with the lambda expression. So this class implementation you can provide it in the lambda expression instead of writing a maybe anonymous class or named implementation class. Okay, so here you can write your whatever person we are getting. Okay, whatever person we are getting, just let's say I want to out your person name only. So this way you can just print out all your person. So these are the complete your list of persons you are getting here. So here we go this as I have already discussed about how we are using the for each. Here for each need your take your consumer interface. So we have a written this way, or you can write the same way, or simply write another way like consumer interface of a person. Okay, na? Consumer, and you can write using the this way lambda expression as well as. Okay, so similarly you can now after that here you can pass the consumer object as well as that's also work. Okay, so this way you can implement a lambda expression. So this is the way I instead of writing this object you can directly write this complete code, or how this lambda expression, if you notice this is the kind of if you go to implement consumer interface, if you are going to write a person, and then let's see what trying to here equal to new, this way you can overwrite this way. So this way you can also write here like the same business logic whatever you want. Okay, so just this is your anonymous. Okay, object of person. So in this way you can directly pass this object as well as this is also work here. Okay, so there are multiple way you can pass in the lambda expression, or you can pass your anonymous function, or you can directly implement maybe directly you can implement the class object as a class consumer person consumer, or you can say implement consumer in this way, person, and here you can overwrite accept method, and here you write your business logic. Okay, so in this case you can also create the object, and here you can pass. So in this way you can, this is also works. So this is the different way you can use lambda expression. So here you can say, so here first maybe this is the consumer interface, so you have a person, then simply say dot person dot stream dot for each you can say new consumer. This is implemented this way, it works. Okay, or you can create your maybe this is the anonymous function, so you can say key I am going to using this anonymous function. This is the anonymous function, the same times you are creating the object, you can in this way also works, or you are using the maybe separately maybe consumer interface. Here consumer interface implementation, in this way you can also pass here. Okay, or directly you can pass this way. You complete this line of code. So this way we can use your any lambda expression. So in complete all the example, I am going to use the implement your lambda expression, your functional interface using the lambda expression. So any functional interface you can implement by your implementation class. In if you are implementing class, you can pass the object of that class in your function that take a lambda expression, like your functional interface object, or you can create your anonymous class, and anonymous class object you can pass in your here, or you can directly use the lambda expression and pass your lambda expression object inside your code directly here as well as, so directly code you can pass here. So in the all in this all example I am going to use this last statement in the lambda expression. So let us just move this code in the function, so that key, okay, for example static void for each, yeah, for each example, for each example. Okay, so this way you can use, and if you run its works, not an issue. Okay, here you can works, it works in this way. So all the example just so that he all the way all the example it's works working. Okay, this works. So now let's our example on which we are talking now, you know key what is this. Okay, these are the implementation of your functional interface. Filter function, here in this case for each function taking the object of your consumer interface. So this is the your implementation of your consumer interface accept method. The reason is that consumer interface is a functional interface where you have defined only one accept method. So this is the definition of your accept method. Okay, so what we are just trying to get, let's write the same. Now let's say we get a person that just we have a stream, then we have just say key filter, filter is the method this that take your object of your predicate. So you have to create the object of predicate filter, and the filter if you can create, if you know the filter method take predicate, a predicate have a one test method. So you have a writer that take one input argument and return the boolean. So this method definition we can write as a lambda expression. Okay, so this say they take one person object input, and what say filter out all their gender is the male. So just let's change the uh, person dot sex equal to male. Okay, here, and here I am just want to the only. After that I am going to dot filter out, and if filter get a input one person object, and they are going to just print your s out. S out they are printing their person dot get name. So in this way, if you run, this is return the list all the here I have to change the name. Okay, so they return all the name which uh, which are all are the male. Okay, here you can do anything, so whatever you want to print. Plus you can see complete, we are trying to say complete object, there you can print complete object, all are the male. Okay, so here your first, here your collections list of your persons, and after that you have a stream of person, and then a stream of person, one element passed with the filter is the intermediate operations, they retrieve one element and check this person is a male, then just next function for is a printing male, then second element if it's still male, then go to the, if not male just go. In this way one by one these we are going to use the operation. So please be in this code, please be aware this is the filter method. Take your filter method, take your object of a predicate interface. For each method, take the object of your consumer interface. If we have any interface method take, we have to provide the implementation class, and that implementation, this class override the particular interface method, and that object you have to pass here. So you have to directly pass the this complete interface this overridden method logic itself here, instead of writing the separate class or separate object by the lambda expression. So the same things you compare the same following print all the mails contained in the collection with a for each. Okay, so this is the for each way, and this is your normal for. You have a one list of person, you are retrieving one code, and after that just checking the particular person's is the male. If male, then you are printing output. The same thing you can write using the stream, java stream. Okay, so in this way you can say change your, let's say here, okay, that leave it. So let's talk about we have a again another, we are, if you want to calculate the average age of all male. Okay, so hold do first we have a your list of person, then you have a stream, after that we have you apply your filter out all the male, then just get only age, and just to average them, and then just get a double of this, average unit double, and then print it. So in this way, these three are your intermediate operation. This is your final output. Let's do. So if we are trying to say all person dot stream, that then we have to filter person that is the only male, and after that this is the return complete object. From this object we have to only need the your uh, need only retrieve age. So you say person dot age, we have only here complete object. From complete object we have just only get one object map, and after that we have to just do average, and average return your if you just print as variable. Okay, so this is the, they return your optional your object. So instead of optional you want to concrete value, then just dot your get as a double, and that is your complete s out. Okay, if you run the, here you are able to get the all average of all your mail. So here what you did is, first you are trying to get the list of person, then stream, getting the stream. For each stream, one by one elements are passing here. First pass one element, check the person is a male, yes, then return just only from complete person object they have only retrieved age, we are age. Okay, and after that they are completing on all the one by one, and after getting all the age, and they are just getting the average it. So these set of API available, and here also you have to notice till now we have a read the filter take your predicate interface. This is the interface, the implementation class that provides the test method. You have to pass the boolean. So here we pass as a lambda expression. Similarly, this is the map to integer. They take kind of one interface known as a functional interface. A functional interface have only one method. Okay, you have to provide the override method that take one input and return some integer variable. So here we have to pass is as a method references. If you go to this method, this is the your only return the value. So this is the kind of you can write this way, or you can write the similarly your from here. Instead of writing it this way, you can write dot my print with a person object, one input pass, and that person is a person dot get age. Okay, in this way you can also pass. So if you have no, this is the we have to only get one value. So we have used the method reference as well as to pass any functional interface, or you can directly say ki this is the interface, take one input argument, return another output argument. So this is the map peer interface. They could take one input argument and return a output as a one input argument. So this is the case here. This is the one your input argument, and this is your you are returning as is integer. So this is the complete implementation logics of your interface implementation class. So this is the way you can see whenever you are whenever you are talking stream, after filter they return the new stream, and then they return the new stream here. So all these are the intermediate operations, they return a new filters. Okay, so whenever you invoke the map to int operations, return the new stream of your int stream. If you look this here, okay, this is your list of stream, and then you are a filter object, then you are getting the here int stream. they're returning another string. Then you see what optional value and then actual value we are getting here. So this way, similarly, as a key, you can here we have two options, or you can use the method reference to provide the any functional interface implementation, or you can use your lambda expression, your input, and what kind of output this method return. So this is the method reference is a very concise way to using. So just this is the preference way, but you can directly pass the implementation of a function interface using the lambda expression as well as. So this is the way you can general preference way you can, if feasible, you can use method references, or you can use the flat. So if we talk about the for each in detail, just for each functions, let's these are the your all the operations till now we have discussed are the your like a filter, like a for each, like a map. These what we discuss, these are your operations. And so if you're talking about the for each, why we as a for each instead of manually you can do for each like iterator, but they have a kind of used terms, internal iteration. So generally whatever we are doing on manually for loop known as your external iterator, whatever doing on the stream dot for each, they have in concept of your internal iteration. So aggregate function do not contain method like nest to the instruction to the process like a next element in the iteration. Okay, so internal delegations, uh, uh, internal delegation, what the application determine the what collection is iterate, but how to iterate the collection. So generally, whenever you are talking about the two iterate, now one is the internal iterator, another is the external iterator. In external iterator, we have to as a developer inform ki what the next element going to the process. But in the case of internal iterator, JDK determines ki how to iterate, not we have to tell. So in external iterator, your application determine both what collections are you going to iterate and how to do it. But in external iterator can only iterate over the element of a collections sequentially. Internal iterator does not have this limitation. It can uh, it can more easily take advantage of the parallel computing, which involve in the dividing the problem into the sub problem and solving this problem into simultaneously. So this way, if we are using the for each internal iterator, that help us, just you take this is my collections, you take a decision as an internally dedicated decision how retrieve data and how process data. So and if we are using the internal iterator like a for each, so they process element from the stream. Okay, the aggregate operations process element from stream, not directly from your collections. Okay, so they also called stream operations. So this internal iterator as a stream operation, and they support a behavior as a parameter as well. So you can specify some lambda expression as we discussed in the lambda expression we can pass it in a parameter for the most aggregated function. So generally all the aggregate function are streams operations, you can say take input as a lambda expression. Generally they are designs, they are majorly depend upon the interface. That interface is a functional interface, and implementation of this functional interface we can pass as a your lambda expression. So these are the all the filter, or you can say map, or you can anything. These are highly depend upon your interface. All they are looking that you can pass the interface object. An interface just define your contract. This is your functions. Someone use this interface, then they provide the implementation of this function. So the implementation of this function you can pass in the body itself. implementation of let's see, this is your function interface, the implementation you can pass directly in here. So this is the stream, all the stream operation all depend on your interface. An interface is a function interface that have only one method, and one method definition logic you can pass directly using the lambda expression inside your while function invoking. So till now we have uh, a readout about the, we have a list of person, all the person. We have just retrieving one by one using the your filter, and filter outing let's go only mail part, and we have collected the all mail, and after that we have performed some map operation, retrieving only age from this complete object and just taking the average. So in this way there are some concept of filter, map, and reduce, you can say. So here we are going to some reduce. What the filter method take? If filter method take one input and return one output. Similarly, map, filter, maybe if you have apply some filter on the basis of condition. Let's keep filter operation. You have a list of persons. Okay, list of persons. You have a 10 list of person. The filter might be filter out is the only male, so might we were getting only two male candidate. So input and output can be very depend upon your condition match. But in the case of map, you have map always take one input and pass to an output, pass one input, pass to another output, one input, pass to another output, just transformation from one object to another object. In our case map, what we are getting a person object, from person object we are retrieving the only int, that is age of a person. So map and just like a one to one. But the reduce operation, what the average here do, our reduce operation average, this is the age of male, age of male, age of male. Let's get five male age. They are going to do reduce. They are going to do reduce, make a plus and divide by the count and return one value, your double value. So this is your reduce operation. So your average is the reduce operation. Sum is your reduce operation. They are getting the input as a stream of the value, but producing only one single value. So these are the some reduce method. So stream offers some reduce method, the general purpose reductions operation, like we have to discuss like sum. These are the reduce operation. Let's see here. Let's we have all the person. I want to sum of your my all the age. So here is out, and we have a all person, then just a stream, then and after that okay, so we have to sum, and we cannot the sum of person object, we first need to your all the age. So we have to map to your int and say ki person have a only age map to him, and after that we just sum it. In this way you can just get the sum of all the person, sum of all the person. So these set of you can say operations available. Here is your map, here is the mapping, here is the reducing. Mapping means here first we have a retrieve one person object. Person have a multiple field. Person have name, age, something. From here what you convert? Only retrieving the age integer. From object you convert your int value. Similarly for person 2, converting. So map is just conversion from one types of object to another types of object. And after you are getting the all int, this is the int of age for all the age, and then you apply the sum. Similarly, these are the generally operations available like sum, but you can manually instead of using the sum reductions operation, you can manually use the reduce function, and manually you have to say ki I am going to reduce this function. So here not using a sum, the same sum what would do, sum take generally if you are going to sum take two value and just plus it. The here you are giving the complete own manually reduce function, map and reduce. So let's do manually. Let's I write this out and I say here only get all person, then stream it, and then let's keep filter only. I want to filter out only person have a dot equal to only female, and if only filter out, and after that we just map. We are mapping what we are mapping only need age, so you say map uh, person object, you can get person dot just only getting the only age person, and after that you say I want to reduce. So reduce is a kind of operate that take your one either your identity, another is a binary function. Binary function take a two input argument and return one output. So let's we are going to reduce operator, reduce operator. First, in if you notice, if you are going to the sum, so what is the identity for sum? First, we have to think. Let's key if we have a number 5. If you add 0, this is always return 5. For 0 is the identity for your maybe sum. If you are talking about the multiplications, so your 0 is not multiplication. 0 1 is your identity. If you multiply 5, the same output it returns. So here in the case of initially just like 0 is identity function, and then we have to take a 2 number, let your a number and then b number. After that you can say ki I am going to a plus b. So manually you have to reduce, and this way you can get the complete as let's output here also filter out only so that we getting the same result. Okay. Okay, here you look, the both are the same result. So here what to do, here we are going to specialize functions of your our stream API as well. Here we say no, I am going to manually submit. For manually submit, I am going to reduce function, and I pass this is the first two value, and that's perform the sub operations, and this is the zero identity functions. So how identity function here works, initially whenever you're writing a manual code for summing a number, generally you take a sum equal to 0, and then we loop then loop from 0 to all the your number, and then sum is equal to you are writing like a sum plus your number, what the number. In this way, this is your one by one number, and this is your carry value return whatever. So this is the your actually one by one value, and one is the your carry return, carry return, carry return. In this way we are passing. If you try to check it, you just write here. Here just write in this syntax. Just you trying to for your reference is out, just print this a equal to plus a, and then the plus b equal to plus b, and you can say return a plus b. Whenever you are writing any lambda expression using the more than one or two line, you have to use your curly brace and close brace, and then your if method return, if you return value, you have to manually return a specimen. If you run it, and then you look how they are doing the mapping. So here you look, this is your additive function A, additive functions A come here, and now this is your first person for TH, for TH come here, for 0 plus 40, 0 plus 40 return, and then is 40 come again the next your carries. And then new number, new age 44, 40 plus 34, add 74, again go to the next day. Then next number, next age 24, you add 24 and return to the next day, this way and this way. Finally we are getting here. So these are the just your carry parts. Okay, your initial number, and this is your new number, whatever for each filter, whatever filter come, which person come, which person come, which person come, in this way are they are going to reducing your operation. So this is the, you can manually check. Okay, what the value come. So generally for your purpose, you can write this way as well as, so for knowing how internally as reduce function work, reduce your 0 comma a comma, you can say carry comma number, yeah, age, and then you can say your carry plus age. So I think it's clear how the map filter reduce works. This is your filter, okay, and this is your map, and this is your reduce. So here is your collections, your list of person p1, p2, p3, and this is the stream of function. This is your stream of functions. First take one pass to one of person here, apply filter, then apply map, then apply reduce. Then next element, apply filter, apply map, apply reduce. Next element, apply filter, apply map, apply reduce. So stream is built on the set of operation known as a pipeline. So as you discuss, your reduce function take your identity function. So for identity element is the both for like initial value, reductions, and default result would be the no element in the stream. So in the case of you are applying the sum, your default value should be 0. If you are going to the star multiplication, your initial value should be 1. And similarly, next your reduced take a object as a accumulator. Accumulator is a function take a two parameter, like here two parameter, and the partial result of reductions. And here what you do, just you want to make a plus operator and then return the value. So this is known as accumulator function. And so complete, if you're talking about the reduce, so reduce manually you apply the reduce with your initial value and your accumulator, or you can use the almost if you want to work on integer, they have a specialized method for int. Just map to int and get the element here. Here you say only are mapping, we're not going to specialize. Here what you say, I am mapped to int. So they this all the int stream operation provide your sum function and division max function, min function. But on your object flat map, they have written a complete object, they have written a stream of again integer, and now we have a manually perform. So here is the int stream is a specialized stream. So generally as a java as a platform library offer you some int stream, long stream, double stream, specialized stream. you can get the benefit of that available methods. So these are the reduce operations. So or you can manually write your reduce function. That is the for sometimes your customized logic needed, then you have to manually need to write or provide the reduce function implementation. Sometime the fix already used like a plus max mean average, these are the standard operations if you are going to do. So why you are writing a code? Why not java platform offer? The java platform offer a specialized stream like int stream, like your long stream, double stream, float stream, in this way. So here also suggested it also suggested here ki it would be more efficient you to update the existing collection. Okay, so which is so whenever you need, you create own collection, own implementation, or you can use the existing java api. So till now we have a study about the first filter filter, then after that we study about the map, and after that we study about the reduce. Here we have a list of n element element, and according to a filter condition, maybe here you are passing the list of element, maybe which n conditions meet true, those n are passed to the your next number. Let's key have a four element meet the condition true, the four element passed to your map function. Map generally, if they need to four, again pass to the four to the reduce function, just converting from one types of object to the another types of object. The map is the one-to-one conversion transformation. And filter what reduce say all the value with the help of some receiving the all the value, receiving all value, and help of some maybe plus operations, division operations, they are going to reduce and finally return one value. Okay, so this is the filter map reduce work. In this reduce, sometime we have to use the some like collect function as well. So these are again the as a Java library offer you the very exciting function known as collect. So on the reduce you are doing, or you can use the collect function as well as. So collecting generally is I want to just collect all the value in the form of list, in the form of set here. So for that we have a collect function. Just not want to just printing on the screen. What don't want to hear perform reduce operations. I want to just collect the all the value here, collect all value here, and return to maybe some list, some collection, some set. I don't want to here perform reduce operations. As per my business logic, later you can do the sometime they jdk offer you out to a collect method, just collecting all the data, and after that they have a rich number of api method available on the collect, and after that you can again perform some setup operations. Let's look how this collect method help us. So generally collects are a highly rich api. Let's see talking about the uh, we have a filter, then we have a map, and then we have a collect. Okay, so let's see in this case our example, I want to collect all the male age. Okay, so how will do list this out. We have a all the person dot stream dot, we have a just filter out person person dot get gender double equal to, let's key male, and after that you are going to I'm going to uh, collect collect. So collect is a function that you have to take example. Let's take a collector. Okay, this have a two implementation. we'll discuss. One is the your take collector collectors, another is your supplier. Manually we pass just like a reduce, we have a manually pass this kind of your function. We'll look the both. Let's first using the collectors. So collectors is interface, and they have a collectors collectors they have a utility method given here. They return the list of collectors. Just I want to maybe all the to list. So here we have to not the reduce here, just we have to collect the list of again. So here what here we have filter and then return out all the again map filter another. So let's keep on to return the all the names, maybe map here say map function person to person dot get name. But okay, if you run, they list out all the name, all the name. Okay, so sometime you have applied your stream, then you have applied your filter, then apply your map. After that you want to collect something. So after collections might we I want to list here the list of name, all the stream of name. Here the stream of name, I want to collect again a stream to the my collections. I want to just say collect and collect a to list or to set or to map. In this way, a collect method provide the list of collectors. Okay, so if you take this collect method, collect take an interface a collector. A collector is a functional interface. They have a kind of a, this function you have to pass manually. Okay, okay. These kind of what happen. Collector is an interface, and here you pass the supplier, you pass the accumulator and combiner. In this way you can implement manually. So as sometime you need manually business logic to implement the collector, you can do, or by default java as a help for the developer, they pass implement one the collectors class, and collector class return the list of your lots of your utility methods. Okay, so here I want to just a to list. So manually you can do manually write to port or to it. So let's key if we want to manually do it, then we have to let's key I want to manually I want to just average. Okay, so how will do? Let's key first manually. So manually what it is, we have to use the collect function, then you have to pass your supplier, then your accept, then your combiner. So manually you can write these classes and get the for average. So let's write manually, then it think how use the annual functions. So for that first we have to write my own class. Okay, that is we have to write one class that implement this consumer interface and provide your average logics. Okay, let's write the let's key I write the class a averager. Just implement int consumer, and that we have to override the method implement method. And here you know I want to average, so average the need kind of some variable like your int first count, and we have to take one int total. To average we need initially 0, okay, and then we have to, in the case of accept one value we are accepting, then we simply say our total equal to plus to value, whatever value we are getting, and after that we have to write a public average method. Average should be in the double, so you have to write average method, average method, and just return the your return if your total greater than 0, then total greater than 0, then return your total divide by your count, and r return 0. Okay, and here generally whenever dividing this would be the double output, so it just convert to the double so that it will take a double output. Okay, and then we whenever you are going to the accepting, at that time you have to also your increment count ki how many number of value you are getting, plus 1. Okay, or simply say count, not an issue. Okay. And this way, and this is the we have to pass as well as the combiner. This is the one, the public void combine take another averager, other, we have a 2, and then what say our total equal to other dot total, and similarly count equal to other dot count. In this way you have write to your own uh, averager. Okay, you have to write your own averager, and now just look like here you have to filter out this concept. So here say I'm not going to use first, let's s out. I want to get person dot stream dot let's key filter person dot uh, equal to male, and then they say map to we have integer, map to int person dot, you can say person dot get age, and here we say I'm going to collect, and collect we have to pass your supplier, my supplier, your average, and then the new object you have created. Then say you have to pass your accumulator, means we have accumulator int consumer, then accept, so average accept, and third parameter you have to pass your combiner. I have written combine method as well as set combine, and then this return your average object, and then after that you can say average, and just this way you can receive. So manually sometime you need some customized logic, you have to write your average, or if you want to same instead of existing, you can use the, so instead of this I can say did this out, and this is dot get as a double value. In this way you can also look the same, both are the same output. Okay, so here what the as a API, as a stream API, have a very flexible. You can write manually or collect, and whatever the collective logic manually you pass, whatever kind of collector you want to implement, or you can use a specialized stream. Here you have the int streams. Okay, now from int stream we have a function like just average, and that average. So these are the some standard operation like sum, average, max, mean, count, some statistical data as a Java standard API offer for us. We have to just use them. Sometime you need to write your complex logic, so you have to manually collect them and provide your collector. Here I need to collect as average, averager, so I provide the averager. So this elf has to write your here you have options, or you can write in this way, or if you look this code here, if you look this code, they have a written like this way. If you look this code, similar the you manually have to overwrite, or you can say here the same thing you can manually do, or you can just try to just 1 minute. I'm trying to, instead of writing my own class, I can manually write code in this lambda expression itself instead of writing a class. How say, how write say here, say I need a object that in this case our averager, we have a two object, count and total. So here you can directly create key, we have a lambda expression pass here, they return just a object new long long of two size. Okay, one object is created here, and what to say, Acho, this is the averager. I have to just change here what here, what in accept method we are written here. In accept method we have written like this, count plus plus and value plus plus. The similarly logic you have to put here. So they say you are receiving your list of object, and comma your age object, and you can just override and say key whatever list we are getting, we have a first your count, similarly they have written implemented here. Okay, so whatever your value we are getting, just manually write here as well as. So you can say key our list, you are just here your list of sorry ll of 0, you can say equal to 0 is for your plus plus and 1 for data. So 0 plus 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 and semicolon, and L of 1 your plus plus equal to plus plus equal to your data part, your a data. Then this way this, and then still again here you to combiner also kind of need again implementation of your again here implementation like LLNRR. Here you can simply paste the same way here what we have to implement here. Okay, and then here whatever you are returning here in the case of your look here, we have a and then you have to apply the manually this operation. So that is the also one way after collecting, and you have a there is no average method, and then you have to, sorry, you have to just remove out and remove out. They return the your like your variable list of longs, and here you can say s out. Here you let's key avg. So this way you can manually, instead of writing class, manually you can overwrite, and both case you are running, it will be the same. Or you can averager. Okay, okay, this is the unnecessary code. Okay, both are the same. So what are the I am here explaining? You have an option. You can manually write a collect with your own classes. In this class you have provide your object and provide your accept method, provide your combine method, or instead of writing class you can manually write your complete using the lambda expression. Don't write a new averager class. Here you have a write first. Here you are creating one new object. That averager have a two field, total and count. So here we created the two object for array of long about two averages. First positions you are holding for count. Second positions you are holding for your total value. And this is the combiner. Combiner you are just whatever the original, just original plus and the other. The same combiner function. This is the combiner function, and this is your accept function. So we have an option. You can write manually class, or directly you can use the lambda expression. So in such way here, the implementation already same implementation your int average class provided. Okay, so you are looking like your collect method, and then you write average code, or similarly you can use your inbuilt average method. The same I so here your implementation, same implementation as JDK library providers. So we have two options. If JDK already provided library, you can use this. Or sometime need some customization, some tweak logic, you can manually write your class and provide your collectors. Generally, always generally we are a Java as a platform offer lots of rich API. We can just use it collectors. Here we are just want to use the collectors toList. This collectors to utility method provides the lots of your collectors implementation. Okay, in this way we can use our collectors. Okay, please we have option. Whenever you can use the collect manually, then you can provide this kind of your collector implementation. You will provide one supplier, okay, and that is your factory method. Then you provide your accumulator. In the case of our accumulating the number total and value, and the combiner just one object, two object, three object, all the result we have to combine. Okay, here k averager 1, averager 2, averager 3, averager 4, and finally all are the you are going to summing. So we have options. You can manually provide your collectors, or you can use the existing library like collects utility classes. So let us some more example about the collects. As I discussed, key collect operation is the best suited for your collections. So here example, let's key put the name of mails number in the collection. So let's give we have all the stream, filter the only mail, and after that mapping the from person object to the only retrieving names, and then we have providing the collect. In this collect method we are not going to our own provider. I can say I'm using the library, Java library collectors utility class, and say just convert all the names into my list to list. They have use just like we are doing here. In our example, here here we are all the main the stream of list, and now we are collecting to the list. So this version of collects take one parameter like collectors. Collector is interface that you can manually implement, or this utility classes provide lots of collector to you. So this encapsulate the functionality as argument collect operations and require three argument like your supplier, accumulator, and combiner. This all the functionality is all already provided for us to use as per our reach. Let's another example. This is the one use of your toList, toMap, toSet. Let's say I want to only set. Here let's say I want to toList instead I want to set. So here say south we have a all person dot stream dot just all name. So map to person all name. I'm getting all name, and after that I'm going to say not reduce. I'm going to collect, and I'm to provide collectors are to join. Here we have another collectors to join. They return the list of all the string. Okay. So this just comma separated joining a value. If you want to, this is the value. But you want to some maybe comma separated, you pass your separator. Here I say now this collectors joining, they know this is my string. Here no, this is the my list of person, then stream of person, then we only map from person to name string, the stream of string. From a stream of string I want to collect and the comma separated string. So we have a comma separated strings. So we have a lots of method collectors like here again s out let's get person dot stream dot map like person dot name dot uh, collect. I want to set. Okay, so I want to convert in a set, means don't want to duplicate the name. So here you find maybe there is in duplicate name. Let's add some duplicate name here like same same one is 40. Okay, and if you run it, so sometime you want to list, sometime you want to. Okay, so here in this case there is the same only one. Yeah, let's first to list, or you can say options, you can say to list. So these collectors utility class provides the lots of collectors for you. So here you look, this your set, and this is your to joining to the string comma separated list of name. This is the list set of name. This is your list of name. This is the list of name. This is the set of name. This is the comma separated name. This is the comma separated name. They have a same two times set. You have only one time set, and here the same two times. So these collectors class offer us this kind of a utility method as per our need. We have to use. That's take that take us lots of time, save our times to thinking and writing own collectors for these situations. So now another functions about time to, let's go on to grouping the member of collection sometime. So this is the one operation, grouping by. This collector says okay, we till now have studied join function, to set, to list, to map. This is the one of grouping by. Uh, this operator return the map, whose key are the value that the result from applying the lambda expression specified by its parameter, and which is called your classification function. If you want to group by, let's key gender. So all the we are getting a two output group by gender. We have a two gender, male and female. This is the male, this is the female. So what are the male and key the male, and all the males value object, and then female all the female. This kind of map we are returning. So let's example s out, and here say all stream.stream, then just collect, and collector say okay, I am going to the I'm not provide collector, I'm going to use existing collectors dot grouping by, and grouping by you have to pass the function on which, see this is the person object, and person object I want to person dot six group, then you are let return it. Then this is your here your one map contain the key male, these all are the male, and similarly then your next this is all the female, this is the female key and all are the female. So in this way you can get complete your this is your here you have a list of person collection, then you're converting the stream of person, and after that just collector say collect grouping by your so here we have a get a map of list of the your map contain the your first gender male, and here the list of your male, multiple male, simply female, and your list of a female. So this is the group this is the list of person. So in this way we can provide your grouping. So these are a very simplest way, just grouping the list of your person on the basis of your category, or the basis of your name, on the basis of your person, whatever you want. So these kind of mapping function we can use. Let's say another example about the retrieve the name of each member in the collections. Okay, however I want to grouping by gender, but I don't want to get the complete person object. Here we are getting complete person object. Here in the output we are complete person object. I don't want to person, I want only the name of those, what are the so that is the concept of your downstream collectors. What is the downstream collector? Here you are just grouping by your key name is your gender, and after that you are here either your male or female to and here in output you are getting a list of your list of person. So I don't want to complete person object here. Here I'm from the person have a name, id, age. I want to only retrieve their name. So here say ki from here again map, here is the mapping from person. I want to convert from person object to your only string object, want to get a name only. So here I'm saying again mapping get only person, and whatever the person come again need a collector. If a multiple name 1, name 2, name 3, so what we have to do again the return the list of name. So again it's a downstream, again you are going to apply some mapping and again collecting. So let's example. So here you try get person dot stream dot collect you say collectors dot grouping by, you are grouping by say key person dot may and group, then here you say this is the list of person, here the list of person. Now I don't want to list of person, I want to list of name only. So again I have to convert from person object to your string object. So again need your mapping. So this is the downstream. This is your upper stream, this is your downstream. Again you are going to here this list, you are going to again apply a stream of mapper. So let's here say, so how to do in the same group by function itself, group by function you can say comma, and then I say I am don't go to manually provide, I am say again collectors, and that say key mapping. I want to mapping only. I am getting a person object. I am getting a person object for each person. Give me person dot name, person dot name. Okay, person dot name, and we can say comma. If you are getting the name 3 4 5 person, though those person is not one object, you can say just again say collectors to list, connect to list. So in this way, or you can simply say here a method reference as well as simple key person dot name. So just you run it, and now you are written taking shift only the male. This is the name of male person, and this is the female person. So instead here with the male and complete person object have all the person object. So from this person object we map only name, and after mapping we again say here say we are mapping from person object only get a name, and after that we have a lots of name. This is the same, this is the same again, this is the team, lots of name. So name 1, name 2, name 3, then what to do, we collect in the list. So this is the list of name. So this is, you can say, downstream. So here you can say this way. Okay, so here till now you are getting the here the list of person. So here list of person again say ki no, no, from list of person I am going to again apply the mapping function, means ki again your and then say ki return from person object map to the only name. We are getting the multiple names, just say ki again collect them and combine again and return the list. So in this way you get the specific function. This is known as a, here this is known as a downstream. This second parameter known as a downstream. So this is your downstreamer. So first your key, and that is the downstreamer. Means again you are going to apply the again stream function. Here again we have a, here is the list of person, here we have list of person, and after that we apply stream and collecting. Here again we are saying this is the list of person, here the list of person. From here I am saying again going to the mapping only retrieving the name, and after retrieving the name here we are collecting them. Similarly we say collect them to the list. So here is the downstream. So we have to know sometime upstream then downstream to downstreams. And to show this group by operation example, I take two parameter. One is the classification function. First is your classification function. A second your instance of again collector. Here you can pass again collector, and collector you can implement the complete your mapping and collectors. So in this way collectors that run that Java runtime applies to return the another collector. So collectors that Java runtime apply the result of another collector. So be very handy function grouping by operations and the collect function. We have a like a list of value, then again apply grouping by, and next example we have discussed about the mapping, again the downstream collector, and downstream collector like we just map convert from person object to the name, and this way you can say multi-level of reductions happen. So whenever you think maybe top level reduce method, and inside again reduce method. So as per our needed, the multi-level reduction is supported in your Java. So let us one more example. In this case, let's see, I want to apply again some kind of a retrieval. So sum of all number. First, you are grouping by your complete list. We have a list of person. List of person. You are grouping in all the two category. One is the male category, one is the female category, and we want to sum of all the male and sum of all the female. Okay, so how to those? First we have to filter with the case of grouping, yeah, and after that again we have option the reducing, and here we have again you have to apply your reduce function. So let's example here as out get, then stream, then you can collect and say collectors. I am collectors start grouping by, I am say group by your person gender, and after that I am saying no, I am going to reducing them. Collectors dot averaging collector dot reducing. I am say collector dot reduce. Reduce again sign initial discuss in reduce, take your identity. Here I am going to the sum, the identity function value 0. Then what you are going to say? I want to age same. So you say person colon, you say age, and what we have to do? We have to same say int streamer, int stream, int is integer, uh, integer, and colon under sum. We are some function here. The in this way you can just sorry, this is the comma you have to pass here, and this way you are getting their complete group, first group by your male and female, and that after the list of person you are again applied to their your sum. So here is the sum age of all the, this is the all the person name, and this is the again you apply the sum of all, and this is the list of your female, and apply the sum of age here. So this is the way this collectors offer the set of downstream as well as. So first first you have a list of person, then you collecting the again the your all the male and female and the list of person. Then after this is the list of person. From list of person I am going to reduce with the sum function. I am going to sum all the age. So I am returning from first converting to the person object to the list of age, and after that age we have to apply the integer sum function. In this way we are able to apply the some kind of tweak. And this is the collectors class offer lots of utility method, like we have used group by, reduce, collectors are toSet, toList, toJoin. These are very handy method, and we have to use. And this reducing again the this sorry, this reduce function which here we have apply, which here they have take a 3 parameter. Okay, so manually collectors have some reduce function as well as this reduce help us to write your own customized logic. If you need to write the 3 parameter, first your identity function. If you want to sum, in the for some case identity value is 0. After that you have provide the mapper, means we have a person object. From person I want to only retrieve the your age part, the other read mapper, take and after that third is the operation. What kind of operations you are going to perform? I want to perform sum. So you seek integer dot sum value. So in this way you can perform these kind of operations. Sometime you want to average, not only the sum. You have a apply directly average. Just I want to average of all the members of each gender. Average sum of the member of each gender. So it's very flat. You can just list. We have a list of person. Then you can see stream. I am going to stream it, and after this, it's just for each gender. So I am collecting, and after collecting, I am say key collectors. I am say grouping by. grouping by, on which basis I want to group by on the basis of your gender, and after that I want to again get your average. So I am say collectors, collectors dot average integer long double whatever you want to average int चाहिए average int, and then to provide your person is just done, just done. Just you, if you write the same line of code in the manually, you have to, this is the average male salary and average average female age. So here this collectors functions offer lots of utility method, and manually if you writing going to write this code take a larger to larger times. And here just in this collections of object I want to group by, or you want to average it, you want to reducing some operation, or manually you can say reducing or providing some averaging int, or you are just mapping, and then after collecting them, or you have some tool set, toList, to join, these set of rich ABI available in collectors. So here again the I'm say key now this is the complete not a complete thing, the minimum just some set of rich API I am given some example, so that कि Java stream offer lots of usable methods for me. We have to know these are methods available in our API so that we can use. So we have to discuss about the first about the Java stream. Okay, and stream, after that we discuss about the pipeline. Stream is a sequence of your element. This is not a data structure. Okay, and pipeline is a sequence of your aggregate operations like for filter, for each map. And after that we have a study about the filter function, map function, reduce function. Filter is just filtering your value, and map is just a transformation from one types of object to another types of object, maybe from. And reduce function just reducing your maybe sum, average, down, whatever the reduce want to say you have to reduce. And instead of reduce function we have to use your collector as well as collect functions need a collector. And Java provide the, you can provide manually collectors implementing your supplier and accumulator and compiler, or you can use existing Java collector class. They have a offer the rich set of API, like we have used collectors dot toSet, toList, toMap, or you can say grouping by, you can say everything it, or you can say again map, again downstream mapper, and again toList. So these lots of set of API available. Here my only request and suggestion, please try to use this collectors class utility method. Collectors class offer lots of method that are very handy and useful methods. Just if you know these set of methods available in collector class, then you can use it. So and how you know these kind of classes already Java as a platform offer us, until you are not doing some practice. So please manually write some example and try to use this method. And until you are not going to using this method, you not feel you don't know this kind of API offer by the platform. So the only my suggestion, please go to some own writing some dummy program, dummy code, and play with this set of API, and then you feel what kind of a benefit, what kind of a rich methods available in the JDK. We have to just use and take the benefit. In last here again, I'm like to say a big thank you for watching this video.